How do you handle security in Java Spring Boot applications? If you are developing applications using Java Spring Boot and are concerned about security, you are in the right place. Let's break down how to keep your applications safe and sound. First, always use HTTPS for secure communication. This means configuring your application to use secure sockets layer or transport layer security. By doing this, you ensure that data transferred between clients and the server is encrypted, preventing any interception or tampering. Next, implement authentication and authorization using Spring Security. This framework is built into Spring Boot and helps manage user identity verification and access control. You can set it up to requiring login credentials for accessing protected resources and restrict actions based on user roles. Another important aspect is protecting against cross-site request forgery. This type of attack tricks authenticated users into submitting unwanted requests. Spring Security provides CSRF protection by default for web applications. Make sure this protection is active unless you have a specific reason to turn it off, like when working with stateless REST APIs. You should also validate and sanitize user input. Never trust incoming data blindly. Use Spring's validation annotations to check input types, lengths, and formats. This practice helps prevent injection attacks, such as SQL injection or cross-site scripting. To avoid SQL injection, use parameterized queries or Java Persistence API repositories. This means you should never concatenate user input directly into database queries. Instead, let these tools handle input parameters safely. Consider enabling method-level security as well. This allows you to restrict access not only at the URL level but also at the method level within your code. You can use annotations like pre-authorized to specify which roles can invoke sensitive methods, ensuring that only authorized users can perform critical operations. When working with REST APIs, implement token-based authentication such as JSON Web Tokens. This method helps maintain stateless sessions. Additionally, configure strict cross-origin resource sharing policies to control which domains can access your API endpoints. Applying rate limiting is another effective strategy. This protects your backend from brute force and denial of service attacks by limiting the number of requests a client can make in a specified time frame. You should also use content security policy headers. These headers reduce the risk of cross-site scripting and data injection attacks by controlling which resources the browser is allowed to load. Do not forget to store secrets securely. Keep sensitive information like passwords, API keys, and database credentials out of your source code. Use environment variables or secure vaults for managing these secrets. Lastly, regularly update your Spring Boot version and dependencies. This helps patch known vulnerabilities. Conduct penetration testing and code reviews to identify and fix security issues early on. By following these steps, you will create a solid security foundation for your Spring Boot applications. This approach protects your APIs, databases, and server-side logic while keeping things straightforward and manageable.